So I think we've all seen similar slides to this a bunch of times the last couple of days, so I won't spend much time on it. But the high-level view of SEBA is we have a bunch of residential subscribers, and we want to use SDN to connect them to the internet. So we're interested in setting up a data path from a residential gateway at the subscriber's premises through an ONU that will add a C tag to the packet through the OLT that will add an S tag. The packets go across the aggregation switch that's forwarding on based on S tag to a BNG, which then strips those tags, and the packets go out to the internet. Right, so this is what we're trying to configure, and the software stack that we're using to configure this starts with Volta on the bottom layer. So that is abstracting OLTs and ONUs from various vendors. You don't need to worry about what vendors are supplying these, because Volta is hiding that and it's abstracting them into a logical open flow switch. Then on top of that, we have ONOS, which is programming the subscriber flows into Volta and into the AG switch. It's also doing some packet processing for EA poll packets for authentication, and it's relaying DHCP packets to the upstream DHCP server. And then at the top layer, there's NEM, which is doing configuration of all these other pieces. Down beneath it, it's encapsulating provider-specific workflows, provider-specific policies, and it also has operational features like FCAPs for monitoring and alarms and things like that. Right, so that's the high-level picture of what SEBA is doing. So the emphasis of a lot of the SEBA work has been on production environments, on integration with a production environment, slotting into an existing carrier's infrastructure, and then providing tools to help you operate SEBA in that environment. But suppose that your personal focus is not really on production just yet. So suppose you are a potential ONF partner, and you've heard about SEBA, and you want to try to evaluate it and figure out if you should get involved in SEBA. Or suppose you are a SEBA developer or a QA engineer, and that you want to run integration tests and end-to-end tests on some code patches to make sure that they don't break the basic functionality of the system. So for these kinds of users, maybe there's not a lot of value in running on the real hardware. And in fact, it could be a bottleneck to productivity, because purchasing, installing, managing these OLTs and ONUs, that has some overhead to it. So if we have virtual hardware, it makes life easier. We can run an entire SEBA pod on a single server or even in a VM. And that kind of configuration without real hardware, with everything just virtual, is good enough for some users who are just doing development or testing or evaluation of SEBA. Right, so that's the focus of the SEBA-in-a-Box work. It's leveraging PONSIM and Mininet to virtualize away the hardware. So Volta's PONSIM module we're using to virtualize the RG and the ONU and the OLT. And then we're using Mininet to virtualize the AG switch. It's an OVS switch now, and the BNG host and the DHCP server. So that's all just going to be a topology in Mininet. So SEBA-in-a-Box is fast to install. You can install it in about 10 minutes. It's downloading, the install downloads pre-built Docker images from Docker Hub, so there's no code to build in your local environment. It's pretty easy to install SEBA-in-a-Box. So we give you a make file, so you download a repository and you run make in there, and it goes soup to nuts. It sets up the single node Kubernetes cluster for you. It installs Volta and ONOS and XOS and Mininet and configures all that stuff to talk together. It's lightweight, so it can run in a VM on your laptop or an EC2. So in EC2, I've been using an M1 large VM, so with 8 gigs of RAM, 2 virtual CPUs. This is only 10 cents an hour, so that's a pretty cheap development environment. And the SEBA-in-a-Box installation is customizable. So the installation proceeds through installing a bunch of Helm charts, and it uses local copies of the Helm charts, so you can modify them, change them to install different images, to install. You can change the makefile to install new modules, new Helm charts. So if you're a developer, it's a good platform. So here's a picture of the data plane in SEBA-in-a-Box. So these gray boxes that I'm showing you are Kubernetes pods, Docker containers running on Kubernetes. And this picture is flipped around from the picture I showed you a minute ago that had the RG on the left and the BNG on the right. So just keep that in mind. Excuse me. So there's 3 things to note about this picture. So the first is in this Mininet container. So this is emulating the topology upstream of the OLT. So there's the AG switch in Mininet, as I mentioned, that's an Open vSwitch, and there's a virtual host running in Mininet that is standing in as the BNG, and it's also running a DHCP server. A second thing to note is, so what we want to do here on the data plane is we want a layer 2 data plane between the RG and the BNG. All of this is running on Kubernetes, and Kubernetes is pretty opinionated about how the network needs to look. In particular, the default Kubernetes networking is all IP. It doesn't really easily let you do layer 2 connectivity like we want to do here between the RG and the BNG. So what we do is we use the CNI plugin, the bridge plugin, which lets us create Linux bridges that containers can connect to. So we have a Linux bridge PON 0 between the RG and the ONU over on the right, and then another one between the OLT and Mininet. And the third thing, so this dotted line up to ONOS represents EA-POL packets and DHCP packets that are trapped to ONOS from the OLT. So when the RG authenticates, the EA-POL packet goes to OLT, matches a flow rule there, and is trapped up to ONOS. Likewise, the same thing happens with DHCP packets, but in this case, packet out for DHCP packets actually happens at the ag switch, and then they're forwarded to up to the DHCP server running on the BNG. So this is kind of an overview of the data plane that we're building in SEBA-in-a-Box and how we do that. So here's an outline of the demo, in quotes, that I'm going to do. I'm not actually going to run a live demo during this talk. I think it's kind of confusing because it involves switching back and forth between a bunch of different windows. So instead, I'll just show you some screen grabs. But what we'll do is do some inspection of different elements of the system, look at the Kubernetes pods that get deployed by SEBA-in-a-Box. We'll look at how the devices appear in ONOS and also in Volta. Take a brief look at the bridges that get set up by the CNI plugin, and then take a look at the XOS GUI, where there's this object called the AT&T Workflow Driver Service Instance that kind of encapsulates the state of the system in terms of what's happened already in authentication and DHCP, and just kind of, for a particular subscriber, represents what is the state of that subscriber. So then what I'll show you is going inside the RG to showing you what how to invoke the 802.1x authentication. We'll see how the state of the system changes when we do that, running the DHCP client to get an IP address, and then pinging the BNG. So when you install SEBA-in-a-Box, it sets up a bunch of Kubernetes pods. And in the Volta namespace on Kubernetes, these are the pods that are running. So most of them are standard Volta pods that are installed with any Volta installation. But these three are the special ones that are installed by PONSIM. So this is the OLT and the ONU and the RG that I showed you in a couple of slides back with those gray boxes connected to the data plane. Right, so that's set up by PONSIM. And then in the default namespace, these containers are many of them set up by NEM, by XOS, and these ones here are the ones that correspond to things that I showed you on the data plane slide. So there's Mininet running there. There's the ONOS, where we're only running a single node ONOS cluster right now, so we don't have any high availability from ONOS right now. This third one, the PONSIM pod one, that's the thing that loads Tosca specific to the SEBA-in-a-Box setup into XOS. So this is where the configuration of the OLT and the ONU for SEBA-in-a-Box is coming from. All it does is it's just a job that loads some Tosca and then exits. So it's just configuration. So taking a look at the devices, so the top of the screen shows information from the ONOS CLI. So there's two devices. The top one corresponds to the ag switch. So this is just Open vSwitch and Mininet. And it has a couple of ports on it. One of the ports is connected to the PON1 bridge that I showed you. And then the other one, it connects to the BNG, the virtual host that's the BNG. The other device is the Volta logical device. And you can see there's only 2 ports. There's an NNI port, and then the other one is the uni port. So down at the bottom is the devices in Volta, and you can see that the uni port, the PONSIM ONU, in Volta, the corresponds to the uni port in the logical device. Okay. So just to show you, I mentioned these Linux bridges that get set up by the bridge CNI by PONSIM. So there they are. Each one of them has 2 interfaces connect to it. And the PON0, as I mentioned, connects the RG to the ONU. And then PON1 connects MiniNet with the OLT. So this is really useful to know about if you are trying to, say, debug traffic on PONSIM. So knowing about these bridges, running TCP dump on them can be pretty enlightening. So looking at the XOS GUI, before we've done anything, this is just right after the system has come up. So as I mentioned, there's this AT&T workflow driver service instance that describes the state of a particular subscriber data path. So at the very beginning, everything here is just in a waiting state. So authentication state is awaiting. No 802.1x has happened yet. DHCP state, there hasn't been any DHCP. So that's the initial state. So now at the top of the screen is the command to enter the RG container that's running. And so in there we can run the WPA supplicant command. Let's see, oops, let me go back. To start the authentication. And so you can see here it prints out a bunch of messages, and eventually it says authentication completed successfully. Then it just hangs, so you hit Control-C and get out of that. So now authentication has happened. And if you look at the XOS GUI, this same AT&T workflow driver service instance, now the authentication state has gone to approved. So the authentication succeeds. ONOS generates an event on the Kafka bus that goes up to XOS, and XOS sees that now the state has changed. So now back in the RG container, we can run DHCP client. This won't work until authentication has already happened. In order to run it, first we need to wipe out the IP address that Kubernetes has already assigned to the interface in this container. So we get rid of that, and then we can run DH client, and it generates an error. That's fine. And then we get an IP address that's on the same subnet as the BNG. On the data planes slide, I think I forgot to point this out, but the BNG has an IP address of 172.18.0.10, and its DHCP server is serving that subnet. So DH client has succeeded. We have an IP address, and as I mentioned, don't worry about that error. It has to do, I think, with Kubernetes is mounting this etc resolve.conf file in the container because it thinks it's controlling networking, and it doesn't like it if you try to overwrite that. Right, so DHCP succeeded, we can go back to the XOS GUI, and now we see that the DHCP state has changed to DHCP-ACK, and now we can see the IP address that has been assigned to the RG, and we also see its MAC address. And there's a lot of other information in the XOS GUI that I'm not showing you. There's information about OLTs and ONUs, and you can drill down into subscribers, and you can see like the set of IP addresses that has gone out through DHCP. This is just one view of this particular workflow. So if you're interested in seeing more about what kind of information there is in XOS, I would encourage you to go check out the SEBA demo over in the adjacent room. OK, so finally, after all that work, we can run a ping. And as I mentioned, the BNG host is 172.18.0.10. And so it works. Yeah, not a very exciting demo, but there's a lot behind it. OK, so the summary is, so the goal of SEBA-in-a-Box is to be a real SEBA pod. It's just using virtual hardware, but otherwise, functionally, it's working just the same as a normal SEBA pod would. So SEBA-in-a-Box, I think, is a good on-ramp for the community to get involved, start getting involved in the SEBA project, or at least starting to take a look at what's there and getting kind of hands-on with it. One thing I noticed is so we have a Slack channel where people are asking questions about SEBA, and since we created SEBA-in-a-Box, roughly half the questions on Slack are in the context of SEBA-in-a-Box. So I think that people are already starting to pick up SEBA-in-a-Box and use that as a way to familiarize themselves. So I like to, I don't know if this is true, but I like to think since half the questions are about SEBA-in-a-Box, that it's doubling SEBA's popularity, because people are checking out SEBA that might not have before. We're already getting some community contributions to SEBA-in-a-Box as well. So there's been interest in, OK, I don't have an OLT and an ONU, but I do have an OpenFlow switch. So can I use the real OpenFlow switch and a real BNG with SEBA-in-a-Box? And so somebody has done that and contributed documentation on how to do that back to the project. And there's also work, so the PONSIM already supports multiple ONUs and multiple RGs. But there's some work to do to integrate that with the Helm charts we use to set up PONSIM. So someone else is working on that and is contributing that back. So we should soon have SEBA-in-a-Box where you can run something a little bit, a topology a little bit more interesting than just a single OLT and ONU. So that link has instructions on how to set up SEBA-in-a-Box. I think it's pretty straightforward, and so if you're interested, please give it a try. So that's it. Thanks. So I have time for a couple of questions, if anybody has some.
So if I have VirtualBox and I create VM, I can easily install SEBA-in-a-Box?
Yeah, it should work in Ubuntu 16.04 VM as long as you have enough resources. It should just be a matter of you run make and wait 10 minutes.
Enough resources means 8 GB RAM?
Right, yeah. And a couple of virtual CPUs, and I think maybe you need like 30 or 40 gigs of disk just to be on the safe side. But yeah, it's pretty lightweight. So we used to have in previous versions of Cord, we had Cord in a box, which I don't know if anybody has is familiar with that or has used it. One of the big differences between Cord-in-a-Box and SEBA-in-a-Box is that SEBA-in-a-Box now includes Volta, whereas Cord-in-a-Box didn't have Volta. It had VNFs that were running in VMs on OpenStack. And so because it was using OpenStack and because it was using OpenStack compute hosts that were virtual machines, it was significantly less lightweight than SEBA-in-a-Box. It took at least an hour to set up and required a pretty beefy physical server to run that. So SEBA-in-a-Box, yeah, unfortunately, I don't have a laptop that has enough RAM to run it, but I think it could run on a laptop pretty easily in a VM. Yeah?
What is the target for the multiple ONF? What is your expectation when it comes to...
Oh.
And also, do you have any consideration to support multiple OLTs?
So the first question, what's the target for multiple ONUs? I think, so the hard work has already been done there by the contributor, and it's just a matter now of kind of cleaning up his work and figuring out how to integrate it with the Helm chart. So I would expect that should happen pretty soon, like maybe next couple of weeks. Can we add multiple OLTs? Yeah, I think I do think that that's possible, and it would be nice to have. There might be some more work to do in terms of, I guess I'm not familiar enough actually with PONSIM to know if anybody has tried hooking multiple PONSIM OLTs up to Volta, but I'm not aware of any reason why that wouldn't work, and I think it would be a nice feature to have. So yeah, exactly. So the other tool for emulating the scalability is BBSim that Keita mentioned, and that just recently was integrated with SEBA-in-a-Box. So you can, when you're setting up SEBA-in-a-Box, you can choose between PONSIM or BBSim right now. I guess as I understand it, the main difference though is that BBSim doesn't provide data plane. It's just control plane. So PONSIM is a little bit more full-featured there. Yep.
Install script, does it handle the Kubernetes installation, or is it directly installed separately?
So it does install Kubernetes for you, the install script. If you just a single node Kubernetes, and if you had your own Kubernetes that you wanted to install on, that should be possible, but I don't think it's directly supported by this script right now. The issue is that in order to use the CNI plugin to set up the bridges, you need to do some specific configuration to the underlying Kubernetes setup to enable that. And so yeah, the script does that, but if you have your own, then it's not impossible, but it would take some more work. Any other questions? Yeah.
Question was just a remark, and thank you, because for the Volta test automation, this was really useful when we migrated from PONSIM to PONSIM v2 and Kubernetes. So definitely something very useful.
Great. I'm glad to hear it. Cool. All right. Well, thank you. And